Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Addino Dimas. I'm from Naval Architecture and Marine Engineering major, batch 2019, with the NPM of 1906356916. I also happen to be in the same group with Maria Deandra and Teguh. So today I would like to do a presentation about analyzing 2D trusses problems using OpenModelica software. Alright, so but for now, first thing first, I would like to explain a little bit about linear algebra, which is a system of equations that can be represented as a product of matrices or as an augmented matrix. It is also can be defined as equations of AX equals to B. There are also special types of square matrices with unique properties. The properties that can be seen by us is this example, which is a product of matrices and augmented matrix. Here are the examples. Right, so I would like to also explain about direct versus indirect method of equations. First one is the direct method, which when we calculate the solution after performing a finite series of computational operations that can be defined also as direct counting. For example, the methods are Gauss elimination method and Gauss Jordan method. And then the indirect, when we approach the solution by improving an initial guess until the error is negligible. So we use iterative approximation. For example, there are Jacobi method and Gauss-Seidel method. So about those methods, I would like to also explain about the Gauss-Jordan elimination method, which we do when we solve systems of linear equations to find inverse and invertible matrix. We get to find this application on the chemical equations to also aeronautical engineering. And then the Jacobi method is when we continuously iterate the equation, the algorithm until it is converged. And then the application that can be found is in electric circuit simulations. Right, so in this method of using OpenModelica, there are 3 steps that we will do. There are pre-processing phase, and then the solution phase, and then after that, the end phase is the post-processing phase, which I will explain it later after we find the exercise. And then here is the example of the exercise that was given before that we need to solve using the OpenModelica software. So my group chose number 4 of the exercise, which is the members of the truss shown in the accompanying figure have a cross-sectional area of 10 centimeters square and are made of steel with the elasticity equals to 200 GPa. Using hand calculations, determine the deflection of each joint, the stress in each member, and the reaction forces. Verify your results. Right, so it is known that we have the elasticity of 200 GPa and then the area of 10 centimeters square. And here are the things that was asked. So yeah, we get to see here in the picture that we have 4 trusses where there are one truss that is divided by another one of truss. So yeah, they are also connected with nodes, and each truss, each element of truss are connected with 2 nodes. For example, here in truss 1, there are 2 nodes which are node 1 and node 2, and then node 2 and node 3, node 3 and 4, 1 and 4, and then 2 and 4. So yeah, in this one truss that is also divided into, we get to see the length that is each of the distance equals to 1 meter each, and then the height is 1.25 meter, and then there is an external force of 4 kilonewton with the angle of 15 degree. There is also an external force up here with the same value, which is 4 kilonewtons, and the same worth of angle, which is 15 degree. Okay, so from this known exercise, we get to categorize the element by each node, which I just explained before. Make a table for properties of each element, such as nodes, angle, area, modulus, and length. So the nodes will be divided into two nodes, which is node I and G. I and J. Sorry. For example, element 1, we have node 1 and node 2, element 2, node 2 and 3, and then etc. And then in element 5, there is node 3 and 4. So yeah, we use this calculation using OpenModelica software. So step 1 is we discretize the problem into nodes and elements. With the function of with the model of trusses, we get to do this algorithm with the code of, for example, n equals to 8. It is the global matrix that is also equals to 2 points connected, and then there is also a parameter of frill a equals to 0.001, which is the area in meter square, and then the elasticity to the power of 9 pascals. Yeah, so the G or n point n right here is the global matrices. We get to see right here, there are 8 global matrices, 1, 2, 3, until 8. So step 2, then we assume a solution that approximates the behavior of an element. So as we have found before, there are 5 trusses. Initially, there are 4 trusses, but one of the trusses is divided into 2. So so there are a total of 5 trusses. So for example, in the truss 1, sorry. Okay, so in the truss 1, the angle is 0. It is a degree between truss and yep. So it is explained about the stiffness of matrix, and then in truss 2, for example, the degree is also 0, and then in truss 3, the degree is 90 degrees. The truss 4 is these written degrees, etc. Yeah, so for example, in truss 1, there are 2 nodes, right? They are node 1 and node 2. And then, for example, in truss 3, there are nodes 2 and 4. And each of the node is also defined as these equations. For example, integer p1a equals to 1, integer p1b equals to 2. Yep, and then step 3, we can develop equations for elements. This is the specific codings or algorithm for equations for developing equations for elements. So we see here, for example, x equals to modelica.math.cos y square modelica.math.cos y, etc. And then in step 4, we assemble the elements. Yep. So there are 5 elements known. Um, yep. So in this function of local and global, we input these codings in the algorithms. Yeah. So in the step 5, we apply the boundary conditions and loads. So there are boundary conditions that is attached or fixed to one of the focus that we have in the exercise. So for implementing boundary conditions, for example, in this code, we have a loop, right? For example, for I in 1, in n loop. So for example, if it is, for example, if the result is 0, we keep on looping the algorithm. But if we get the result of 1, then the program will end. Okay, and then the step 6, we solve a system of algebraic equations simultaneously. Yep. So in this picture, there is a certain code that will be written in the program, which we can see right here. X equals to modelica.math.matrices.solve A and B. It is pretty much the same from the previous example. For I in 1, in n, then loop. Yeah. So if we have the result as in the picture, then there's going to be an error. So we have to minimize the error by eliminating the element of errors. Okay, and then after that, the Gauss Jordan is ended. Right. So the step 7. All right. So the previous steps actually concluded the deflection that we wanted to find before. And then after that, the step 7 is the step when we want to also find the other information, which are the reaction forces and the internal forces and normal stresses. So the algorithm is pretty much the same as well. But in this example, the algorithm is more simple, which is X equals to A times B minus C. Yeah. So in this case, we need to also eliminate the elements of error. And then we get to end the programming of reaction trusses. So here is the result of the displacement graphic, which is asked for the questions point A. So the graphic can be seen when we run the operation on OpenModelica software. And then after that, we get to also gain a result of reaction forces graphic, which can be seen in the picture down below. Yeah, using the running program of OpenModelica as well. So that's all from me. Sorry for all the mistakes. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.